Lesson 6.4 addresses graphing sine and cosine when we start to shift the graph either horizontally or vertically. A horizontal shift is called a phase shift, and a vertical shift is just a vertical shift. So the first thing we're going to start with is horizontal shifts. You will know that it's a horizontal shift because you will have plus or minus some value within these parentheses. The trickiest part here is to understand the direction. So in this case, we've got x plus 3 pi over 4, which means that we need to move left 3 pi over 4 units. And that's because there's a plus. If there's a minus, we move to the right. So what I've done here is I've just shown the graph sine of x. This is our basic sine graph. What we'll need to do is identify each of the major components on this graph. And we will need to shift each one of them to the left 3/4 of pi. So if I start with this point here at 0, 0, if I'm moving it to the left, this is half of pi, 3/4 of pi will be right here. And actually, you know what? I will do that in a different color. I'll then move this one to the left. 3/4 of pi will be over here. And I'm going to proceed with each one of these and move it to the left 3/4 of pi. So the last one that I'm shifting is this one because here I don't have enough space. And I will continue with each one of those. So 3/4 of pi will be here. And now I can sketch this graph. So I have moved every single one of these points to the left. Here I'm not starting with the cosine graph being given to me, so I actually have to do this particular graph from scratch. So the first thing that I want to do is look at the coefficient on x, and in this case, their coefficient is 1. So what that tells me is that the period is 2 pi units. Then the next thing that I think about is the pattern of cosine. Well, I know the pattern of cosine starts at 1, 0, -1, 0, 1. Then I look at the amplitude as -2. So I'll multiply each one of those by -2, and I get -2, 0, +2, 0, -2. So from here, I actually graph what I've got happening. So 0, -2, pi over 2, 0, pi 2, 3 pi over 2, 0, 2 pi -2. And I'll graph the same thing backwards. Now what I will do is my phase shift. Because this is minus pi over 3, that means I have to move to the right pi over 3 units. So if I look at my graph, this distance here is pi, so if I'm looking at 1/3 of pi, it's about right there. And it doesn't have to be exact. This is just something that we're going to estimate for the most part. So if I start here and I move that over 1/3 of pi, it'll be here. Move this over 1/3 of pi, about right there. About right here. That one's about here. And then I will do the same thing on the negative side. So 1/3 of pi is about here, 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 and here. We have to do a little bit of work to the next one before we can actually graph this particular function. What I want you to notice is that there's a period change here, but we can't have this 2 inside of the parentheses. So the very first thing we need to do is rewrite this equation. And you have to factor out the 2, which means 2x simply becomes x. But this minus pi is going to end up being minus pi over 2. And the reason is because when we multiply this 2 back through, 2 times x is 2x, which is here. 2 times negative pi over 2 would just become negative pi. Now that we've done this, we can start to work on this graph. So here we have an amplitude of 3/2. We have a period that's 2 pi over 2, or just pi. And we have a phase shift of pi over 2 to the right. You see what I've written here? I will want to see this on all of your problems. So because I know that the period of this is pi, I can write out my 5 numbers from 0 to pi. And this is cosine, so I know that the pattern starts at 1. I have an amplitude, 3 pi over 2, so I can multiply each value by 3, not by 3 pi over 2, by 3 over 2. So this becomes 3/2, 0, negative 3/2, 0, 3/2. Now one thing you should notice on this graph is I haven't plotted, or I haven't given any values here. I'm going to label my graph with these values. So I will do pi over 4. I'll call that 2 pi over 4, 3 pi over 4, 4 pi over 4, and we can of course move backwards as well. And I can plot all of these points. I'll label this as 1, 2, here's -1, -2, so that I've got 3/2, negative 3/2 are easy to find. So at 0, I'm at 3/2, pi over 4, 2 pi over 4. And I repeat my pattern. And I also repeat it backwards. And I can connect my points. Now, I will move pi over 2 to the right. We can also think about this as moving 2 pi over 4 to the right. And then another way we can think about it is I can take all these x coordinates and I can add 2 pi over 4 to those values. So 1 pi over 4 and 2 pi over 4 makes this 3 pi over 4. And then this is already 2 pi over 4 plus another 2 pi over 4 makes that 4 pi over 4. This would be 5 pi over 4. And then this would be 6 pi over 4. So you could think of this set of numbers in pink as your new x coordinates to go with those y coordinates. That is entirely up to you. But there's your 2 pi over 4, and then 3 pi over 4 will be here, 4 pi over 4 is here, 5 pi over 4, 6 pi over 4, and then you can simply continue this pattern as well. Moving backwards, we would go backwards here. Now we'll take a look at vertical shifts. Vertical shifts are a little bit different because they're a value that's either added or subtracted to the entire function, not within the parentheses. So I've graphed cosine of x plus 1, if I'm looking at this on my table. With a vertical shift, you simply add or subtract this value. So you have 2, 1, 0, 1, 2, and you move backwards the same way. And you should notice that the pink graph is simply this blue one shifted up. So let's take a look when we start combining these. We have an amplitude of 3. The period on this graph is 2 pi over 2, which is simply pi. There is no phase shift, but the vertical shift is down 2. This is much simpler to understand. Minus means down, plus means up. So I write out my coordinates for the period. Because this is cosine, I apply my amplitude first, so I multiply by 3. Then I apply my phase shift, which means I subtract 2 from each one of these values. 3 minus 2 is 1, 0 minus 2 is negative 1, negative 3 minus 2 is negative 5, 0 minus 2 is negative 2, 1 minus 2, oops, that should have been a 3 right here, so then 3 minus 2 is positive 1. I didn't label this axis, but I would again label this pretty simply, pi over 4, pi over 2, 3 pi over 4, so that one would be pi. This one's 2 pi, and going backwards I have negative pi. On the x-axis I will make this counting by 1, so there's 3, and here's negative 3. So now I'd simply plot these points. So we have 0, 1. My next one is down at negative 2. My next one is down at -5, which kind of isn't shown, so we'll fudge it right there. Then we have our next one at -2, back to 1. And we move backwards as well. Notice where the center line of this graph is. It's here at -2. Right there. There's your center line. The last graph we're going to do will combine all of these components. So I will start again by listing everything out. Amplitude is -2. Period. I forgot here I need to factor this 3 out. So this becomes 4 minus 2 sine of 3 times x minus pi over 3. And again, the way I know that it's pi over 3 is because if I multiply it back in, 3 times negative pi over 3 will give me negative pi. So the period here is 2 pi over 3. The vertical shift is shown here. So this time it didn't get tacked onto the end, it was in the front. But it's always the thing that's sort of going to be separated from the rest of this by either a plus or a minus. So the vertical shift is up 4. And then the phase shift, we're going to look here. We're going to move pi over 3 because that's a minus. We'll move to the right. So now I will start to list out my values. We go from 0 to 2 pi over 3. If I cut that in half, I get pi over 3. If I cut that in half, I get pi over 6. So I might right here say, oh, let me redo these numbers. If I have 1 pi over 6, this will be 2 pi over 6, 3 pi over 6, 4 pi over 6. So I'm going to call this 2 pi over 6, because then I've got 3 pi over 6. Sorry about that. Let's see if I can erase. And here's 4 pi over 6. The next thing we'll do is we will apply the pattern that occurs with sine functions. So sine starts at 0. Then I will multiply my amplitude by each one of these values. And then I will add my vertical shift. So this becomes 0 plus 4, negative 2 plus 4, 0 plus 4, positive 2 plus 4, 0 plus 4. So here I'll call this 2 pi over 6, 4 pi over 6, 6 pi over 6, 8 pi over 6, and then moving backwards, negative 2 pi over 6, negative 4 pi over 6. And I will plot this whole thing first without the phase shift. Then I will add the phase shift to it. So looking at the values that I need to be working with, we'll call this 2, 4, 6. So we're at 0, 4. Pi over 6 is at positive 2. 2 pi over 6 is back to 4. Positive 6. 4. I'm sorry, this is not a 0. This is a 4. And I can again repeat that pattern. And repeat it going backwards. From here, we'll move everything pi over 3 to the right, or you can think of it as 2 pi over 6 to the right. So this one moves here. So this point is what has moved over. I'll move this one over, 2 pi over 6 as well. And as I progress, I'm just following the pattern that's already there to move each over by 2 pi over 6 units. And as I move backwards, so if this one went here, and this one went here, so that means this one moves here, and this one moves here. So I'll move all of those points over. So each one of these will move over. And I can re-sketch this graph with the phase shift. The last thing we're going to do is look at using some sign regressions. This is something that you'll do when you're given a set of data and you need to come up with the sign function that matches the data. So if you read the problem, in Chicago, we're looking at some average monthly temperatures, 22 in January, 47.8 in April, 73.3 in July, 52.1 in October. We're saying January is the coldest, July is the warmest, and we need to determine a sign function for the annual temperatures. We'll actually do this using our calculator. So what I'll do is I will show you some of the steps that you need to do. First of all, we need to identify some coordinates. So January is month 1, and its temperature is 22. April is month 4. Its temperature is 47.8. July is month 7, and that's 73.3. October is month 10, and we've got 52.1. For this particular problem, we need to do what's called a sign regression. So we're going to take the data that we have, and we're going to enter that into our calculator. So the first thing you'll do is push the button that says Stat, and then you'll hit Enter to edit. L1 is going to be your X values, L2 will be your Y values. So we had month January, we had April, we had July, we had October. Now, I'm going to tell you that for your calculator, this is not enough information. We need to show yet another year of information. So when we go back to January again, it'll be the 13th month. When we go to April again, that's 12 plus 4, it'll be the 16th month. When we go to July, that'll be 12 plus 7, so the 19th month. And then October again will be the 22nd month. Now we go in and put in our temperatures. January was 22 degrees. April was 47.8. July was 73.3. October was 52.1. Then we'll do it again. January was 22, 47.8, 73.3, 52.1. Second quit will get me out of here. I can graph this information by going to my y equals, up to plot 1, and then hit enter. Now you notice that plot 1 is highlighted, so it will produce a scatter plot for us. If we go to our window, our x values went from 0 up to 2 years, so I'll put in 24 months. We can do 2-month increments. That 2 is just going to be the tick marks. For the y values, let's just start at 0 and we'll go up to 100 degrees, even though that's not one of our averages. And then the scale on that, we can make 10. Now I've got a nice curve going on here. To get an equation, what I do is I go to Stat, I go over to Calc, and I need to scroll all the way down. You see this is a linear regression, a quadratic regression, a cubic regression. Here's another linear regression. I want a sine regression. I hit enter, enter again. This is the equation that I get. What I have to do from this point forward is actually write it out as an equation. So the way I write that will be y is equal to, and it tells us a times the sine of bx. So there's a, and that gives me a value for a. So here a is 25.73. So there's a times the sine. In parentheses, I can put that b value, which is 0.52, times x, plus the c that they give me is negative 2.13. Close my parentheses and then add d to the end. That's 48.68. What you can do from this point is take this entire equation, put it into your y equals under y1, and see how well it matches up. The next part says to predict the average temperature in September. Well, we know that September is the 9th month, so if I put the number 9 in place of x, which means I'm going to multiply 0.52 times 9, I could actually type this entire thing directly into my calculator, so start at 25.73 sine blah, 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 blah. Putting a 9 right there, this y value that it spits out will be my average September temperature.